Troubleshooting is one of those things that is really hard to learn because the only way you get troubleshooting skills is from troubleshooting things. And most of the time when you're troubleshooting something, you're not really in an environment that's conducive to learning because everything's down, right? And even whenever you work with people who have a lot of skills in troubleshooting, for a lot of them, it's really hard to explain or articulate why they did a certain thing that they did. It just becomes like this instinct level of operation, which is really hard to convey. So in this video, I'm going to go through 3 of the most common types of troubleshooting that I encounter in my work. One thing to keep in mind is that troubleshooting is part of an overall incident management framework, right? The technical troubleshooting is only part of the things that have to be happening at that time. There's other stuff like communicating to your customers, communicating to your business executives in your organization, and communicating to other team members and documenting what you've done so that it can be either implemented permanently or rolled back if that's not the correct behavior. All of that gets wrapped up into incident management. And if you don't have a lot of incident management skills or experience, be sure and check out this video I did on how to manage incidents. There's a ton of useful information in there. But the 3 types of troubleshooting we're going to cover in this video are system outages, where just everything's down, or a huge percentage or a huge portion of your environment is down. The next one we're going to talk about is build and deploy issues, which you're going to deal with on a very frequent basis. A developer will push up some code and the build will fail, or the build succeeds, but then it fails when you deploy it. And then the third one is code debugging, which is probably the one that you might be most uncomfortable with if you aren't comfortable writing code in the language that you're debugging, but I'll show you how I approach that. It's kind of the same way no matter what the language is. One of the first things I do whenever I'm dealing with a system outage is get the steps to reproduce whatever's being reported. Now, in the case of something being completely down, the steps to reproduce might be,
dude, open our app or go to our website. Nothing happens.
And okay, sure, those are steps to reproduce. Other times though, it's like a little more subtle or a little more granular than that, especially in a microservices type environment where you have different services that are responsible for different parts of your application. And in that case, it's really good to get information like specific browser. If this is a web app, does the problem only occur if you're using the Safari browser, but it's okay in Chrome? Or is it tied to a specific location, like the problem exists for users in Asia, but users in the Americas aren't experiencing the problem? Or it could be a user profile, people who have this permissions, like people who have admin permissions in your application are experiencing a problem, but no one else is. All of those will help you build a more complete picture of what might be going on. And then with that information, you want to try to identify any changes that have been recently done in that section. For example, if you have a problem with people accessing the admin portion of your application, go to the repo for the admin application and look for recent changes. If there was a deploy done right before this incident was reported, then go ahead and grab the team that did that deploy and bring them on to help you troubleshoot this. It may not be related, but it's not a bad idea to bring them on for their expertise anyway. And one of the things that's really awkward for people just starting to troubleshoot is it's okay to call someone at 2 a.m. It really is. If you're on call and you get paged at 2 a.m. and the site's down, if it was important enough to roll you out of bed at 2 a.m., it's important enough for you to roll the resources you need out of bed at 2 a.m. as well. So don't feel nervous about that. It's nothing personal. It's just what you got to do to get your job done. Now, one of the things that can be tremendously helpful in troubleshooting a system outage is having a diagram of what the overall architecture looks like. Let me give you an example. Let's say that we've got some web servers here And then we know that they talk to a specific API server right here, right? And then that API server can do a couple of different things. It might talk to a message queue like RabbitMQ, and it might also talk to a database back in here, right? And depending on what you're trying to do determines which of those it's trying to talk to. So we might have some /user routes. So anything related to our user activity goes and talks to the database. But then let's say it's something like a Facebook or Instagram style app. And so anything that displays on your feed comes from our message queue. So now that gives you a lot of information to work with, right? So we know if the problem we're troubleshooting is something with a user logging in, we might have some issues going across to our database here. Let's add one more component to this. Let's say that our message queue talks to the database as well to refresh your feed. So if we get a problem reported that the user's feed is working, but they're not seeing any new activity, they're just seeing the same old posts over and over, then we can kind of assume at that point that our API is able to talk to the message queue, but maybe the message queue is not talking to the database correctly. And so from there, you're going to want to start looking at logs, right? You'll start looking at logs here at the API. And then when you determine that that's a message queue problem, you'll come check the logs here in your message queue and then troubleshoot it from there. Now, if you don't have any of that information, you don't have that level of details, there's a lot of stuff to troubleshoot here. And the way I try to approach my troubleshooting in that scenario is to break things up in halves, right? So we've got our web, our API, and our backend data stores. I'll go to the API here because it's kind of the middleman halfway in between this stuff, and I'll try to reproduce the problem from there. So if everything works fine there, then I know that the problem is somewhere between the API and the website. However, if it doesn't work from the API, I know that the problem is somewhere between the API and our backend data stores. And so instantly by doing that, I've split the number of components I have to troubleshoot in half, and I'll keep doing that half again and half again until I narrow in on what the problem is. Checking for logs is helpful, but you can't always assume that the logs are telling you what the actual problem is. Let me give you an example. If we take a look at this here and we see this error message in our logs, LDAP authentication binding failed for some user. Now that's a string of text we can search for. So we can open up the code, we can search for that, and we can find the exact part of the code that failed, which may give us some really useful information to where our problem is or where our next step in troubleshooting should go. For example, in this, we know that we're talking to an LDAP server, and the LDAP server is defined up here through config.ldap URL. And this is why I like JetBrains products so much, because I can click on this. Let me make that where you can see it. And it takes me right to where that is defined. And so the LDAP URL is set by process.env LDAP URL, which tells me that there should be an environment variable on the server that's running that tells it where the LDAP server is. And if not, it's going to default to this server name here, which happens to only work in localhost development mode. Key reason I point that out is because you need to verify that the server it's talking to is accessible. And there's a key point there. The server needs to be accessible from where this application is running, right? So it's a good idea to check that the server is up through whatever tools or utilities you have. But it's also an even better idea to gain access to your production server and make sure that that server can talk to it, because you might be able to talk to it from your desktop or your laptop, but that doesn't mean that the server can talk to it. Now that's the case if we have an error message, but we may not always have an error message. For example, if we take a look at this little snippet of Python code here, we're going to try to print some cool stuff here. But if that throws an error, we're going to catch that with the accept command, and then we're just going to print out lol, which is really helpful. It's kind of helpful in this case because it actually does something that LOL would show up in the logs. So we could look at the code and know that something happened to trigger this exception. That may not always be the case though. And what you'll see in many instances is this will do some kind of fallback behavior, but unless the software developer puts in a logging statement that tells you that exception was tripped, you may not know that it happened. So logs are good, but they're not always available and they're not always accurately telling you what the real state of the environment is. So whenever it comes to that level of troubleshooting where you're into the code itself, that may be an area where you're not comfortable with. And that's when it's a really good idea to bring in the developers from that team or someone who does have knowledge of how it works to help you troubleshoot it faster and get to resolution faster. Now, at the same time, once you've identified where the problem is, you're going to want to check like the basic metrics. I'm talking things like memory utilization, CPU utilization, disk space, network throughput. And don't forget like some of the other metrics that may be specific. When you check CPU utilization, make sure that you also check the system load average, because those are two different metrics that tell you two different things about what's going on in the system. Also, if you're working with a Java application, look at your heap utilization and garbage collection. Same thing if you're dealing with Node.js, because it does garbage collection. And if you're using virtual machines, look at your virtualization specific metrics like vmstat and steal time, because those can introduce problems into your application, even though there's nothing wrong with your application itself. Now, a lot of those tie into Linux specific troubleshooting and using Linux commands. So if you need to brush up on those, be sure and check out this video for some basics on Linux and Linux troubleshooting. One last thing on system troubleshooting. There is a huge difference between getting the system back online and fixing the system, right? Whenever you're in incident management mode, your job is to get the system back online through whatever means possible. That may not mean fixing the problem. So if you've got a scenario where throwing additional servers at the problem gets it back up, that's an acceptable strategy, because that brings you back online and buys you time to figure out what the real problem is. A lot of times people who are new to troubleshooting will try to go fix the root cause, and they'll end up going down this rabbit hole, spending a bunch of time to fix a root cause, and then discover that that wasn't the root cause after all, that was merely a symptom of the problem. So first job is to restore service, then use the luxury of time that you now have to figure out the root cause. The next common area of troubleshooting I want to talk about are build and deploy issues. Now, this scenario is whenever a developer pushes code up into the repo, which triggers your CI/CD system, and that's going to go through a series of steps, and those steps fail, right? Now, the way I commonly approach this is I'll start off by trying to run the process manually. And to do that, you need to understand what your CI/CD pipeline is doing. It's usually broken up into multiple steps. Whenever code's committed, it will run the test framework. And then if the test pass, it will do some type of a build process. And then if the build works or is successful, then it will do some type of deploy. So you want to figure out where the process broke in those series of steps, and then try to run that command manually. I've had the most luck with that, because then I run the command and it either works or it doesn't. And if it doesn't work, I get the exact error message. And that's one of the things you'll find common to a lot of CI/CD systems is they'll tend to bury the actual error message that's meaningful to you. Give you a really common example of that is if you use Jenkins with their pipeline syntax. Their pipeline syntax is their own DSL. So then you'll enter in the DSL command that gets translated or transpiled into Groovy, and then that Groovy code gets executed. That's where it blows up. And so you did something over here in the Jenkins DSL, and you get a Java stack trace back, and you're like,
well, that's kind of less than helpful.
But running the command manually sometimes gives you the info that you need. Let me show you a specific example that I encountered this week about that. Take a look at the screen here. This was from an application and it blew up whenever we committed it to CI/CD. And so we've got this stack trace here. Now the thing, if you aren't really familiar with stack traces, the thing is they go like a stack from the top down. So the bottom part of our stack here is the first thing that was executed in our application. So if we take a look at this, it was in the bin folder, the Rails command. That's how this application starts. But that's not really where our problem is. We need to go all the way up to the top here. And so this was, looking at the top here, this was the last thing that it tried to do whenever it blew up. And then the stack just goes down from here saying, well, I did this because this dude told me this, because this dude told me this. And you can follow it all the way back to the start of your application, right? If we look at this though, these first three are kind of worthless error messages. They're something about a spell checker, but the one that stands out, actually just those first two, the third one here, could not load the command, Rails command server, server command. Well, that sounds kind of important. I don't know a lot about Rails, but it sounds like the server command is important, right? We can follow that up with Rails engine is abstract. You can't instantiate it directly. And I'll save you a bunch of time here. So what happened was this actually runs locally for the developer. But when we pushed it up to CI/CD, we don't run it that way out on our production servers. We run it as a Docker container. And so the error that we ended up having here, I found just using a Google search on that Rails engine is abstract. And then I was able to work backwards from there and find out that they had upgraded Rails to Rails 7.0.1, which had a bug with Ruby 3.1. All of the developers were running Ruby 3.0 on their workstation, but the Docker container we were using was running Docker or running Ruby 3.1. That's how we got the error message, and that's why we saw the error message out in production or when we tried to go to production, but the developers weren't seeing it locally. And so that's kind of what I want to highlight whenever it comes to build and deploy issues. It's almost always either just a misconfigured pipeline, which you're going to know as soon as you build that pipeline because it's never going to work, or there's something different between what the developers have locally and what you're trying to execute in your CI/CD pipeline. And when you identify that delta, you can usually resolve the problem pretty quickly. Now, the last type of troubleshooting I'm going to talk about in this video is actually debugging code, which you probably won't do a whole lot of if you're not writing the code, but you're going to encounter it at some point. So you're obviously, it goes without saying, the more familiar you are with the code that's being written in your application, the more success you're going to have. And the most important step to doing that, I think, is the ability to run the application locally on your own workstation. So one of the ways to do that, if you check out the video for my first day on what to do when you get your first DevOps job, I talk through that on how to work with the development team to get it running, because that allows you to do some cool things. Once you can run it locally, it's on your laptop or your workstation, so you can make changes. Even if you don't know how the code works, you can do really simple stuff like print statements, like whenever you get to a certain line, print I am here, and then run the application and you see I am here scroll out on your screen. And different things like that will give you an idea of how the application is working. And the ability to add a print statement will get you a really long way in debugging code. Now, if this is a scenario where you're debugging code for an outage, by all means, grab someone who is very familiar with that code as quickly as possible so you can minimize the amount of time that you're down. And then just because you're on call, I think I mentioned this earlier. If not, I'll say it again now. Just because you're on call doesn't mean you have to resolve the issue. When you're on call, It means you have to gather the resources to resolve the issue. So don't feel like you have to sit there and beat your head against the wall until you magically know how to write code in a specific language. Just go get the resources that you need, even if it's 2 a.m. Look at it this way. If you were an EMT and you picked up a patient who was having a stroke, you wouldn't be expected to do brain surgery on that patient in the back of the ambulance on the way to the hospital, right? Your job is to just stabilize them and get them to the experts who can do that and have the tools and the environment to do that. Whenever you're responding to an outage, it's the same thing. It's your job to get the patient stable and get the patient to the hospital where the experts can take over if it's a scenario that you can't handle in the back of your ambulance whenever you're the person that's on call. So that's kind of troubleshooting in a nutshell. I hope that was helpful for you. It's one of those things that's really hard to explain, but if it was helpful for you, give me a thumbs up, leave a comment down below in which part was helpful for you. That will help other people looking through videos for stuff like this. If you thought the video sucked, click the dislike button. Let me know so that I can make changes to future videos. I mentioned it earlier, I'll mention it again here. If you haven't watched the video on what to do when you get your first DevOps job, that's a really good video to go watch next because I set you up for success with troubleshooting and a lot of the things that I talk about in that video. So check that out and I'll see you in that video.